Hello students, today we discuss about F block elements. So already in the last classes we completed S block, P block, D block. Okay, so already we know this classification of elements into blocks is based on differentiating electron. So you remember what is the differentiating electron? So the electron which is newly entered, the electron which is newly entered in an element is called its differentiating electron. If it is present in S block, P block, N minus 1D, that is a D block. Now here, same, it is also F block also we define as the differentiating electron entering, but it is not in the valency shell. It is not in the penultimate shell. It is present in anti-penultimate shell. So what is mean by anti-penultimate shell? For example, what is the valency shell? Outermost shell is called generally ultimate. We know ultimate means the final. The valency shell, we say it is nth. What is penultimate shell? The penultimate equal to n minus 1. Next here anti-penultimate. Anti-penultimate, it's called n minus 2. Okay. Then last but second, D block define the electrons. If the differentiating the elements in which differentiating electron is present in n minus 1D. Last but one lo D subshell enter అయితే it's called D block elements. ఇక్కడ మనకి F block లో ఏం చెప్తామంటే the elements in which differentiating electron is present in n minus 2f subshell, nothing but n minus 2f orbitals. N minus 2f orbitals lo then that is treated as a F block elements. Okay, so F కాబట్టి F block. Okay, but what is the difference అంటే S and P కేమో nth shell లో ఉంటుంది S block and P block elements కి. So for D block element it is a penultimate shell, last but one shell. అది F block elements తో సేమ్ F orbital లో ఎంటర్ అవ్వాలి, బట్ ఇట్ ఈస్ n minus 2 లో ఎంటర్ అవుతుంది కాబట్టి in definition separate we are mentioning this. Okay, so now we read the definition. How we can define? So the elements in which the differentiating electron the elements in which differentiating electron is present n minus 2f subshell or orbitals are called F block elements. Okay, the elements in which differentiating electron is present in n minus 1 2, this is okay, n minus 1 2 f orbital are called F block elements. If you know in the periodic table, if you observe the periodic table, which elements have this character means lanthanides and actinides. We know the elements which are taken at the bottom of the periodic table in two rows. Our main periodic table lo discuss chestam. So main periodic table body కింద two horizontal rows ఉంటాయి, 14 plus 14 28 elements ఉంటాయి. So actually they separately treated as F block elements because if you observe their electronic configurations, and electron configuration observe cheste we can observe that the differentiating electron is coming at the n minus 2f orbitals. Okay, so what is the general electronic configuration? We can write so general electronic configuration is n minus 2f 1 to 14, because f sub shell lo how many orbitals are there? 7 orbitals are there. So each orbital having 2 electrons, so total 14 electrons kabatti 1 to start 14 to end avutadi. That's why there is a 14 elements are present in one row. So n minus 1d 0 or 1, n is 2. So actually ikkada n is 2, n minus 1d 1 undali. n minus d 1 అయిన తర్వాత ఇప్పుడు for example, okay, we see the elements. So elements చూస్తే we can understand. So this is the general electronic configuration. Actually ఇక్కడ ns2 n minus 1d 1 ఉండాలి. So 0 ఏంటంటే it also takes place in rare cases. So ఎట్లయితే మనకి 3D series elements లో for chromium, copper, the 4s electron ఎట్లా షిఫ్ట్ అవుతుందో, సో అదే మోడల్లో దీంట్లో ఉన్న d1 ఉండాలి. 1 ఎలక్ట్రాన్ కొన్నిసార్లు ఏమవుతుందంటే f లోకి షిఫ్ట్ అవుతుంది. సో f లోకి షిఫ్ట్ అయినప్పుడు ఏమవుతుందంటే n minus 1d becomes 0. That's why we return 0, 1. So maximum elements లో మాత్రం only n minus 1d 1 ఉంటుంది. When some particular elements లో there is a 0 is present. Okay, now we see which elements are under F block. So next, if you see, so which elements are having, so the F block elements are present in 2 series. They are present in 2 horizontal rows. Where they are present, we know that at the bottom of the periodic table. At the bottom of the periodic table. Okay, so called so what are that? One is called 4f series. So what is called 4f series? 4f series are also known as lanthanides. Okay, lanthanides, sometimes it is also known as lanthanons. Okay, so there are also one more name that is called rare earth elements. They are also known as, sometimes they have different names: lanthanides, lanthanons, rare earth elements. Okay, now see what are that elements. So the elements already we know they start from cerium. Okay, what is the cerium? This starts at cerium 58. Okay, next, what is the ending point? It is a 71. Okay, cerium to lutetium. So now we read that elements. Okay, so promethium, the neodymium, so this is PR, praseodymium. Okay, praseodymium, neodymium. Next to promethium, PM, promethium. Next samarium. Next europium. Next GD. Can you guess this? Gadolinium, terbium, dysprosium. Sorry, dysprosium, not prasiodium. Dysprosium, dysprosium, holmium, erbium, thulium, ytterbium, thulium, ytterbium, cerium to lutetium. So what is the lutetium? It is 71. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, the starting element is 58, the ending element is 71. So actually we need to remember these elements, because in some question it is they are there. Just dysprosium belongs to which series, so like that means we have to remember. So no need to about the know the configuration now, just we have to remember which elements are present in 4f series. Okay, so then why they treat it as 4f series? Because the electrons, differentiating electron enter into 4f subshell. So దీంట్లో 4f1 to start అవుతుంది, ఇక్కడ 4f14. ఓకే, అయితే ఇక్కడ 4f subshell ఫిల్అప్ అయిపోద్ది కాబట్టి ఇట్ ఇస్ కాల్డ్ 4f సిరీస్. సో ఎట్లయితే మనం డి బ్లాక్ లో 3d సిరీస్ 4d 5d 6d సిరీస్ అన్నాం. సో వై గివెన్ దట్ నేమ్ 3d సిరీస్ 4d సిరీస్ లైక్ దట్? బికాజ్ దానిలో ఫిల్లింగ్ అనేది ఎక్కడ స్టార్ట్ అవుతుంది, టోటల్గా హియర్ స్టార్టింగ్ అండ్ ఎండింగ్ ఆఫ్ 3d subshell takes place. Scandium to zinc configurations we know perfect. You should perfect the configuration up to 30. This is compulsory. Mana scandium to 13 ఏమంటాం, 3d series అంటాం. సో దాంట్లో scandium 3d1 4s2. What is the zinc 1? Zinc is 3d10 4s2. అంటే ఇక్కడ 3d తో ఎంటర్ అయింది, 3d తో స్టార్ట్ అయింది, 3d తో ఎండ్ అయిపోయింది. That's why that elements are treated as the 3d series elements. In the same way, if you write this configuration, so we don't need configurations, no need now, because they are large atomic numbers. So వీటిలో మనం అబ్జర్వ్ చేస్తే 4f సబ్షెల్లో ఎలక్ట్రాన్ ఫిల్లింగ్ స్టార్ట్ అవుతుంది, లాస్ట్ ఇక్కడ లొకేషన్లో 4f14 కంప్లీట్ అయిపోతుంది. దట్స్ వై దే ట్రీటెడ్ యాజ్ a 4f series element. Now I write the reason why they call 4f series means filling of 4f subshell takes place. So in these elements, filling of 4f subshell takes place. Okay, next one more important. So that's why they called as 4f series elements. Here one more important, why they are treated as lanthanides. Okay. So why they are treated as lanthanides means very simple reason. Simply they started after lanthanum. So lanthanum తర్వాత స్టార్ట్ అయితే కాబట్టి simply they treat as a lanthanides, and their properties and their structures are also similar to lanthanide. So that's why they called as the structure is similar to lanthanum. Okay, lanthanum 57. That's why దాని తర్వాత 14 elements are treated as the lanthanides. Okay. This starts after lanthanum. After lanthanum 57. Therefore, they treated as lanthanides. And their property is also similar to lanthanide. Therefore they're known as lanthanides. Next, what is the other name for it? They are also known as rare earth elements, because in the if you see their abundance in the earth is a very less content. Okay, less amount lo manaki earth lo vastayi kabatti we are able to find them in the earth in very less amounts. That's why they treat as rare earth elements. So next so they belongs to which group? So already మనకి if you observe the D block elements, so D block elements లో జస్ట్ ఒకసారి మనం సిరీస్ రాద్దాం, టోటల్ సిరీస్ కాకుండా స్టార్టింగ్ రాద్దాం. ఇప్పుడు 3D సిరీస్, వాట్ ఇస్ దట్? స్కాండియం, టైటానియం, వెనడియం అప్ టు జింక్. సో వాట్ ఇస్ ద 4D సిరీస్? Yttrium, zirconium, niobium, molybdenum, like that. So now we see what is the 5D series. So 5D series లో ఏమితో స్టార్ట్ అయిన మనకి lanthanum 57, next hafnium, okay, 72. So next ending up to mercury వరకు. So 6D series actinium 89. సో ఇది మనకి F block లో నెక్స్ట్ actinium దగ్గర చెప్పేద్దాం కానీ. So ఇక్కడ lanthanum 57. So actually this 3D belongs to which period? 4th period. This belongs to which period? 5th period. This belongs to 6th period. As last వచ్చే కాలం actinide 7th period లో వస్తాయి, అది కూడా రాసేద్దాం. 7th the 6D series అని నేను ఇచ్చినాం. So that is actinium 89. Next what is that? Rutherfordium. Rutherfordium, that is 104. So now we are discussing about this lanthanides. Okay, lanthanides, so they started after lanthanum. Just now we given the names from 58. So 58 to 71 names ఇచ్చిన మనం, cerium నుంచి lutetium. So they treat as a lanthanides because they started after lanthanum. So ఈ lanthanum మన periodic table లో see vertical column. So ఈ lanthanum తర్వాత they present at the bottom of the table. దీని తర్వాత మనకి lanthanides వస్తాయి, 14 lanthanides. That's the treat is the lanthanides అన్నాం. సో ఇక్కడ ఇంపార్టెంట్, in which period, in which group they belongs, lanthanum. So why we are giving this information D blocks అంటే, సో దే బిలాంగ్, మనం డిస్కస్ చేసే lanthanide ఏ గ్రూప్లో ఉంటాయి, ఏ పీరియడ్లో ఉంటాయి. సో అది మనకు అవసరం. సో ఇక్కడ lanthanum తర్వాత స్టార్ట్ అయినవి కూడా దే ఆల్సో బిలాంగ్ టు సేమ్ గ్రూప్. But actually what is this group? This group is 3rd B group, nothing but simply 3rd vertical column in the periodic table. So starting name to say 3rd B ఇవ్వచ్చు. So general number is, that is also 3rd vertical column, means lanthanides belongs to 3rd period, 3rd group, nothing but 3rd B group. In which period they belongs? They belongs to 6th period. Okay, so bottom నుంచి 1 means bottom మన 7th period. So last but one ఇక్కడ 6th period. Okay, so now we write it belongs to which group and which period. So now I can write so lanthanide belongs to which group and which periods. So lanthanide so belong to 6th period. And which group? 3rd B, nothing but it is nothing but equal vertical column కూడా 3rd వస్తుంది. Okay, 3rd B group in long form of periodic table. Okay, so next some important one. Total how many elements are there? There is the lanthanides, so there are 14 elements. Okay, so this is about lanthanides. Okay, next we see about other F block series ఏముంది మనకి, actinides. Okay, so you have to maintain the nodes, very clear nodes. Okay, next we see about actinides or 5F series. So actinides. So what are the actinides? Same ఇక్కడ actinides are also called 5F series elements అంటాం. So why they are 5F series అంటే we the subshell అక్కడ ఫిలప్ అయ్యే subshell ఏంటంటే 5F1 తో స్టార్ట్ అవుతుంది, ఎండింగ్ విత్ 5F14. So what are the elements? So actinides, nothing but it is called 5F series. So 5F series elements. So what are the 5F series elements? So now we see it starts from thorium. Thorium 90 నుంచి స్టార్ట్, యాక్టీనియం 89, తర్వాత యాక్టీనియం తర్వాత స్టార్ట్ అయింది. ఓకే, సో థోరియం, protactinium, uranium, neptunium, Np, plutonium, samarium, sorry, plutonium తర్వాత it's having americium, curium, berkelium, californium, einsteinium, fermium, Fm. So this first will be capital. So mendelevium, nobelium, lawrencium. Nobelium, lawrencium, that is 103. And what is the starting element? So 90 to 103. These elements start from 90 and ends with 103. Total how many elements are there? Total there is 14 elements. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 elements are in actinides. So now we see why they are treated as 5F series elements. Because మనకు 5F దీంట్లో ఎక్కడ స్టార్ట్ అవుతుంది, థోరియం దగ్గర కాన్ఫిగరేషన్ 5F తో స్టార్ట్ అవుతుంది, 5F1 తో స్టార్ట్ అవుతుంది. సో 1, 2, 3, 4, 5 మధ్యలో కొన్ని అబ్నార్మల్ కాన్ఫిగరేషన్, ఎట్లయితే మనకి కాపర్ క్రోమియం 3D సిరీస్లో అబ్నార్మాలిటీ ఉందో, దే ఆల్సో షో సమ్ అబ్నార్మాలిటీస్, బట్ ఫైనల్ ద lawrencium is having 5F14. Means in these elements 5F series is subshell is filling continuously. In these elements filling of 5F subshell takes place. Okay, so why they are now known as actinides? So already we know the reason. So lanthanides for discuss చేసినాం. Lanthanides so లాంథనం తర్వాత స్టార్ట్ అవుతుంది. ఇక్కడ మనకి సో యాక్టీనియం, సో డి బ్లాక్ లో ఉన్న యాక్టీనియం 89 తర్వాత స్టార్ట్ అవుతుంది, కాబట్టి దే ట్రీట్ యాజ్ actinides, and also their properties also follows equal similar to the actinium. Okay, they starts after actinium. And their properties are similar to actinium. Ac means here actinium, that is 89. Okay, so next so if you observe these elements, so the starting three elements, what are that? Actually thorium. So we write one more point here. So thorium 90, so protactinium 91, uranium 92. So next one key up to 103, that is a lawrencium. So why I am saying again means these first three elements are actually the present in nature. So nature manaki, so nature lo elements ఉంటాయి. Nature means general in the form of soil. Okay, soil lo manaki we are able to get these metals, sorry, these elements in the form of their minerals. So So next 92 తర్వాత ఎలిమెంట్స్ 92 తర్వాత 103 ఎలిమెంట్స్ వరకు ఏంటంటే దే ఆర్ నాట్ న్యాచురల్లీ అక్కరింగ్ ఎలిమెంట్స్, దే ఆర్ టోటల్లీ made in laboratories by using different compounds with the help of different reactions in the laboratory. They are prepared, mean they are treated as the synthetic elements. Synthetic elements means not naturally occurring elements. Okay, they are called as man-made elements. After uranium carbon, they are also known as transuranic elements, mean the elements after uranium. In the actinides, the elements after uranium are called man-made elements, nothing but synthetic elements, and they are not occurring in the nature. Okay, so that's important point of these F block elements. Sorry, these actinides. So lanthanides, all lanthanides present in the nature, but in a very less amounts. So the elements. So in actinides, the elements after this U means uranium 92, are man-made, called synthetic elements. Synthetic elements, they are also known as transuranic elements. Okay, so this is important point. Like if you observe them, so most of these elements, most of not only actinides, most of the lanthanides and actinides are radioactive. Okay. So these points are about related to the actinides. Now we see lastly some points about the total F block. Okay. So just now we discussed about their other names, but one more name, total F block combined just 4F series, 5F series combined. Just see there is one name is there, that is called inner transition elements. So why they are called inner transition elements means very simple. Just if you see the periodic table, we can observe. For example, what are the lanthanides and 4F series elements in manaki? So cerium 58 to lutetium 72. The 4F series. At the 4F series katta munde enti manaki there is a lanthanum 57. So this is ending point. So ending tarvata after 71 here. 71 tarvata 72 hafnium. Ante they are present. Their atomic numbers are present between the 57 and 72. 58 to 71 4F series elements ante these atomic numbers are lie between 57 and 72. So 57 82 మధ్యలో ఉన్నాయి కాబట్టి సో యాక్చువల్గా 57 lanthanum is a D block, that is transition element. Hafnium is also a transition element. They present between the two transition elements కాబట్టి they are treated as inner transition elements. Next if you see the 5F series, so 5F series లో కూడా what is the starting element? Thorium 90. Next lawrencium 103. So these elements actually మన 90 కంటే before element ఏంటిది 89, that is actinium. Next 103 తర్వాత rutherfordium 104. So 104 కి 189 కి middle లో ఉన్నాయి. These atomic numbers lie between the 89 and 104, that is 90 to 103. Here actinium is a D block transition element. Here rutherfordium is also D block transition element. So that's why they are also treated as inner transition elements. Means what is the other name of a block elements? And they are also called inner transition elements. Okay. So what is the reason? This is the reason. Yes, we have to understand. No need to write the separately these atomic numbers. If you want to write, you can write in this model. F block elements are also called inner transition elements. Okay, so this was about F block elements. If you write there a common oxidation number, the common oxidation state of F block elements is so +3. So most of them are radioactive. Next, they are all, so you except uranium. So already we said the synthetic elements. Synthetic elements they are present in man-made elements. They are present in very less amounts. Very less amount at different laboratory. Means, for example, how much uranium is present in that we can't calculate it because earth lo untadi kabatti natural coastal kabatti there is a large amount of uranium is present in the world. But we are able to know the amounts of transuranic elements. ఇప్పుడు ఈ వరల్డ్ లో టోటల్ గా transuranic elements ఎంత పర్సెంటేజ్ ఎంత అమౌంట్ ఉందో there is a calculation is there because total man-made elements కాబట్టి and some a few particular laboratoryలోనే ప్రిపేర్ చేస్తారు అవి కాబట్టి ఆ transuranic elements ఈ వరల్డ్ మొత్తంలో మనకి సో ఎన్ని గ్రామ్స్ ఉన్నాయి సో అది కూడా మనం there is a calculation is there so that a particular counting undi మన దగ్గర okay but no need to know about that calculations. So this was about F block elements. Okay, now if you see the picture, the total picture of blocks, so after completion of the total block you have to draw this. What is the position? Just write the positions of this S block left side. This is P block. This is D block. This is F block. So manaki D block lo how many series are there? So 3D, 4D, 5D, 6D are present. Here how many are there? 4F series, 5F series. Okay, so when it is having the two groups, what are the groups? If you are able to write it, write the groups also. Here 1, 2, and how many groups are there? 6 groups are there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, here only 2 groups are present. Okay, this is about the this was the total perfect information about the SPDF blacks. So at lastly again I want to say that you have to perfect in the total element, total 104 elements. You must know the names and position in the periodic table. Okay.